Hello and welcome back to the show. This is Do All the Things, and today we are continuing our SLO build with the actual board assembly. Oh yes, this is the funner part and the easier part. So I've started doing the soldering of the main boards, and it's a pretty simple process. Pretty much just connect the dots. Seen here, the power supply board's done. And if there's a component like resistors that I think are going to generate heat, I float them a bit. It looks nice, and well, it's going to give them room to breathe. In a lot of these cases, like this 10K, that's definitely going to put out a little bit of heat. So small victory. On the main board, we got a couple things going on here. Once again, I don't put the resistors tight to the board. They're all just a little bit floating. Just a little bit floating. I do that for two reasons. One, this is a guitar amp. It's gonna get hot in here. Even just radiation coming off the tubes, even though they're above, we want room for expansion and contraction. If we put the components tight to the board, as heat causes this thing to flex, and it will, you can't really see it, but it is a phenomenon that exists. It's going to start to stress out the leads and the components. They're going to break at some point, or they're going to, damage the solder joints. That little bit of space is going to give them room to move. Now, there's some more advanced techniques where they, bend little strategic bends and like little dips in there so that they have real expansion movement capabilities, but I find that's a bit overkill, and well, it's going to be time consuming. I guess if you're really good at it, this should be good enough. The other reason why I do that is, again, they generate heat, they got some room to breathe. Component values will drift. Your tone can change as an amp heats up if you have poor components in it. Now, something else you have to watch out for, and this is specific to this kit. There's a bit of artistic license used in the component selection. Some that made me second guess myself. Like, one of the hardest parts of this build is matching the color codes to the value, finding that value on the board. I basically am hunting and pecking. Grab all the 470Ks, then look for 470Ks on here till they're all gone. And Buddy made it pretty easy because the bags are kind of sectioned off. And here he has all the 15Ks, the 39Ks, all the 100Ks. So, you do it in chunks. But something that makes you second guess yourself is this color code here. Well, that, I didn't recognize it first. I'm like, what is that? 47, huh? Oh, it's a 475K. It's supposed to be a 470, but he gave me a 475. For the positions that these are doing, close enough. However, here we have a 2 meg that's supposed to be a 2.2. There's two 2.2s in this, one here, one here. If we look at the schematic, one of those 2.2s is here. The other 2.2 is right here. Now, this is part of the signal chain. This is your actual audio signal coming off this tube. It's kind of important that that's the correct value. Whereas this one is just a ground shunt. A ground shunt of that high of value is gonna have less effect on your tone. That's for anti-pop, just so that, when these switches switch, you hear it less. So in this case, I put the 2 meg here, I put the 2.2 up here. Another thing to watch out for in the case of this kit is in this bag, we have 315Ks. And if we look, 2 of them are these large blue guys. One of them is a little carbon, but doesn't really tell you what's what. It doesn't tell you which one's R57 and R58. It's kind of up to you to know, what goes where. In this case, R57 and 58 are in the power supply, and it says 3 watts on this diagram, on the layout diagram, but it's these 2 guys right here as part of the power supply for the preamp. And then the little one is probably going to be in the audio circuit somewhere here. I haven't crossed paths with it yet, so I can't point it out, but that's something you have to watch out for. These values are going to be the same number resistance wise, but the wattages could vary, and you're going to have to figure out on your own what goes where. Okay, so now we're up against a real fun part here. I've gotten all the resistors installed, and don't they look cute? Well, I derped out an R24. I put the 2.2K in place when it is common knowledge that we're supposed to be changing that to a 1K. I guess it's optional, but I'm gonna have to pull that out now, and it's a wasted resistor because now the leads are cut too short for it to use for anything else really, unless it's another PCB build that's similar. Now the real fun part is these capacitors. they are all using the number codes, which off the top of my head is a little rusty, and we got to start calculating on them. Now, I recognize these guys, 223Js. Those are your .022s. That's one of your common bog standards. Over here, we have 104Ks. Those are .1s, which is also common. These ones, 473Js. These 473Js here, those are your 047. Well, in the schematic, it says 47NF, which is on the phase inverter right here. That's an upgrade from what would have been a 22NF, so that's an 047. Yeah. The thing I'm not liking is that they're not the same. You know, it's kind of supposed to be a balanced circuit, but they're different manufacturers. I'm not sure how I feel about that. Oh, look, we can weave them together. These guys are hard to identify because you can barely read what they say. I think they're 1U. It could be an N, but I'm pretty sure it's a U. It's so hard to read, I'm not even gonna bother zooming in. They say 1U, 10, 100. Indeed, the schematic, this is a different version, calls for 1U bypass on the cathodes. I believe that's what these guys are. That would only make sense because they're 100 volts. Those are the only positions which a 100 volt is acceptable. And yeah, the schematic we have here shows 1U 100 cathode bypass. That's pretty straightforward. These large cans are what's left of the power supply, no problem there. These guys are easy to identify, 47P, 120P, cool. These guys here, 105J, 1UF, 250 volts. I'm not sure where I'm seeing this on here. I guess it'll turn up. Maybe that's an option for the bypass if you prefer that style of capacitor. That's what's weird, like, sometimes you don't know what you're up against until you actually have to install it. There's 4 of them, just like there's 4 of these. The only thing I can think of is that Buddy gave us 2 different options. One of them's an optional bypass here. Oh, that's the optional bypass. So that's 5 1U100s. Guess we have spares. I guess we'll see if they turn up as I proceed. Then we have 3 oddballs here. Now, according to him, everything in this bag goes on that board. 222K. Okay, yeah, stuff going on right here. Trouble peaker. And we only have 1 of those. The next is a 102J. That's the bright cap, which you can switch on and off. So C6, all right. 471K. Okay, so that's a 470 PF. They appear to have given us a high ceramic here. Where would I want to put a ceramic in here? I see but one 470 PF over here, but that's off board. I think that goes to the switching circuit. It says C5 on this schematic right there. According to the layout, yeah, that attaches directly here. That's not an off-board component. There must be another one on the circuit somewhere. Because yeah, there's another one in the bag of off-board components. All right, so I'm gonna get into it now. Again, I'm not really gonna film it because it's a lot of boring editing just kind of doing this. Oh, this is what I'm talking about. You see how that has little bends? That's a heat relief, expansion, contraction. Some of these have it, some of these don't. Some of these aren't gonna sit on the board very well, I think. No, they mostly line up, except, you know, you have a situation where it's gonna bump up against that resistor. So we might have to float them a bit, guaranteed, because there's another little guy that goes in there and it's gonna be too sandwiched. So I guess we'll put the smaller ones in first and see what happens, right? Well, we might have our capacitor choice made real easy for us right now. Because if we look here, if we take these blocky caps and I try to put it in there, the resistors that we got are too fat and she don't fit nice. So indeed, these guys also being 1U, they're 250 volts, but that should be fine. We'll be able to situate those guys a little bit more favorably. You know, we can hover them up a bit like I'm doing with the other caps that are too thick to fit down against the board, you can see. I've also decided that since I have the 2.2K in here already, I'm gonna leave it. I am going to try to see what the effects loop is like on this amp stock before I change it to the mod. Because I did the mod to my Jet City, and I never really used an effects loop until I tried to plug in an EQ pedal one day, and it didn't sound very good. For whatever reason, I didn't like the sound of it. I also noticed that the sound of certain tubes that I like in the effects recovery buffer changed. I might have liked how that tube position was responding to tubes before the mod. So I don't know. We'll leave it like this for now. And because I have the mod on my Jet City, it'll be an opportunity to compare the two because the Jet City is very similar to the Soldano tone-wise. Yeah. All right, it's been some time later, and as you can see, I have all the capacitors installed. It looks quite colorful now. Well, mostly orange. If If you're a citrus fan, you might enjoy this look. And of course, it gets very three-dimensional because, you know, you had to float things. And you didn't really have a choice because you have resistors that these fat capacitors Buddy gave us, they would not have fit right on the board. So we got some artistic impression going on here, especially on the one end. These guys were huge and they were all so close together. Look at all those beasts. That's all just for the presence. That's all the phase inverter right there. Looks, you know, infectious even. Me personally, I prefer my little dealies like this. They're the same kind. I think these are polypropylene film. They might be polyester. I didn't look up the specific parts. These are polyester film. Rumor is polyester isn't the best, but they're good. They sound fine for tone, for amplification. So this is what I would have used. They're a little bit more fragile though, because if you accidentally nip on these with the soldering iron, you burn a hole in them, so you have to be careful. They would have fit better on here. Maybe even looked a little nicer, but the orange isn't bad. I don't mind it. Some things didn't line up. Like look at those resistors right there. Some of the capacitors are very much like that too. Had to get very creative in the bending. And then, you know, jumpers. There were some jumper positions. You just use, you know, the scrap that you cut off to do those. And indeed, even after this board is completely set up, I have these guys left. I didn't use these guys. Even in a section right here where there's a lot of room, there's still not a room. That little send right there, the blocks blocked it. I couldn't use these. I guess they're spare parts now. Try using them somewhere else. These almost remind me of safety caps. Pretty sure they're not though. 1U. The only other thing to watch out for is the LDRs. Mind the polarity. You see how these guys are face up? These guys are face down. They don't all go the same way. Make sure you pay attention. Now our boards are all done. We got a nice looking main board, a nice looking power board. We got all these nice solder joints down here. I'm happy with the way these things turned out. But there's one more board that we're doing, and that's the DC supply board. Basically, we're going to make a nice power supply board to feed DC voltage to the heaters of V1 and V2. Now I did this mod to my Jet City, and it made a significant improvement. Soldano himself says the new models of amp have that improvement added to them. Apparently, tubes were a lot quieter back in the day, and they're just noisier now. I don't know. Most modern amps use DC heaters if they're that high gains, so that's just getting ahead with the times. And it's something that's not built into this amp, but it's highly recommended. Now, you've seen in my assembly video there that I've already made a place for it. Basically, I mounted the choke externally, and where the choke would go internally, that's where the DC board's gonna go. So to do this, you know, you got yourself a hobby board. 2.2 ohm 3 watt. These are metal oxide resistors. Some form of diode or diode bridge. A quad of 1N 407s will do fine. I got this little guy here. It's a W06 diode bridge. It's cute, but its layout isn't ideal because it's going to make it tricky to get the legs to go where I need them. And finally, we got 5 2700U 10 volt capacitors. Now, when I did this at the Jet City, I used 2200U and 1.2 ohm resistors, and it worked just great. Now, the design I'm going with comes right off the Rob Robinette website. He's got this design, and it's actually a really good design. It calls for 330 UF, 330. It calls for 3300 UF and a mix of 2.2 and 2.7. I guess that's his math. My math says 2700 UF is fine. Now, his is spec'd out for 1 to 3 heaters. We're only spec'ing it up for 2. We're doing V1 and V2. So his would be for 900 milliamps. Yeah, maybe you do need more filtering. The 2200s I used in the Jet City worked great. These 27s are going to be even greater. Now, I got specifically the narrowest ones I could find because I wanted to be able to fit them all on this really thin hobby board. His way of doing it is kind of bulky. That'd take up a lot of room in your amp, but you know, a little board like this, it's easy to tuck away. We'd be able to fit the 5 caps, the bridge of the 2 resistors on here, no problem. Mind you, I'm scaling it up to this size here because I got some other support circuitry that I want to throw on this board that will run off the DC, mostly accent lighting. I'll talk about that more later. So I guess tricky because we got to lay this all out, and you know, hobby boards are fun to work with. Just got to make sure we compensate for the fact that there's screw holes here. Now what's great is you find out a lot of these components have a very fixed pattern. There's like an industry standard, so most of them will just drop right onto these boards, no problem. Just like that. Snap right on there. I don't know if that's the best position. I might have to move it. Let's make sure it clears the screw. Yeah, we'll move it over. Now, in his design, you see we have these dropping resistors. There's two reasons why you do this. One, I don't understand this phenomenon. I don't know enough about the theory, but when you rectify AC, you end up with more than you started with. So we start with 6.3 volts. I find the general number is times 1.35. We would end up with 8.5 volts. So we have these droppings to bring that back down. I have ran DC heaters raw dog before, no dropping, and it seems to work just fine. Once the tube puts a load on the circuit, it brings that voltage back down. The other philosophy behind why you have these dropping resistors is an RC network. The same RC network that's in your main power supply. Resistor, capacitor, resistor, capacitor, resistor, capacitor. It filters out the ripple. This tank fills up, and then this valve slows the flow of current so that the ripple doesn't pass through it. So this also acts as an RC, further suppressing ripple. And then at the end, well, we have this weird contraption. You see, even though it's DC, you're still gonna get hum unless you do some sort of ground reference like the artificial center tap or the center tap. We don't have to worry about this artificial center tap because our build has a center tap on the transformer, but the DC also needs to do that. I've used a pair of 220K resistors before with a 0.1U capacitor in the middle connecting to ground, but this method works great also. We just have two capacitors in series and ground goes between them. That's how I did it in the Jet City. It worked awesome. It's tight. Well, we got to get it started here. Start with the bridge, one capacitor. Holding these in place is tricky. Then I kind of have to remember what my positive and negative here is. Okay, positive's that guy. I have this simple process of just kind of bringing leads up to where they go and connecting them together. But let's not put too much solder on it yet. If you're talented at doing this kind of thing accurately, you can create some art. I just wish I had a snip small enough. Oh, we're flying along there. I got the first 3 sections done already. Again, if I think a resistor's gonna generate heat, I float it. Also give me room to work underneath here. Oh, she's tight, but she should be good. Yeah, something like that. So we have some leads intentionally left long. Not this one though. These guys will wrap up against the AC input at some point. Seems so shiny. Well, right here is your main positive. Then your main negative comes here. And then finally, this is going to be our center ground reference. We'll hook that up to ground later. I almost wanted to cheat and connect it to this, but whatever. On the other side, it looks like that. There's a clearance for that center resistor. Floaty. We have one off the side here. A little bit of flare action. Okay, hold the phone here. I think we have another fail. I'm testing my DC board here now. I'm running this 6CG7. It's supposed to pull about 600 milliamps. And if I hook up my meter to the outputs that it's connected to, I'm only getting 4.68 volts. And I noticed, I have a different diode hooked up here because I noticed the diode that's built on, rated for 1.5 amps, was getting hot and was suffering even more voltage drop. I'm dissipating 1.14 volts across one of those resistors, 2.2 ohms. Okay, because I did follow the Rob Robinette schematic, and the last time I built one of these, I used 1.2 ohm resistors, not 2.2. So I'm thinking here, what was he thinking? You have 2.2 drop on that side, and the 2.7, well, I doubt that's the magic sauce. What's the other resistor dropping? The same, probably. 1.14. Oh boy. Yeah, what's Ohm's law have to say about this? Because I didn't actually math this. I'm just like, oh, that schematic looks good. I'm not looking very professional right now, am I? It looks like I have to redo this whole DC board. Well, not the whole RC board, but I gotta pull those puppers off. Let's do a little experiment then. Even this heavy duty, well, that's a much larger bridge. A 6 amp bridge, I think, is starting to overload. Let's bypass one of these resistors and see what happens. 5.5. Okay, that's more what we want. Yeah. So what's this other resistor dissipating now to compensate? 1.26. Yeah, that's close to what the math said. That means I'm probably slightly undervolting my... I should put 1 ohms in there, is what I should, because the dropping's not a bad idea, but... Because yeah, if we take the load off, we're gonna notice, boom, we jump up to 8.3. What happens if we bypass both resistors? Bypass both resistors, we're up to 6.7, 6.82. So we don't really need a lot of dropping. Well, the only problem with doing circuits like this on these hobby boards is you run into a situation where once you've put a component on and like tied this whole tapestry together, taking components off is an excessive pain in the arse. if you have to change something. It's a good thing I left these leads a little bit long so I'll be able to repurpose those resistors. Lucky for me, I got a bunch of 1 ohm metal oxides in stock recently. Geez, this DC board project's just definitely gone awry. Ugh, I really freaking spliced them on there. Oh. It's probably easier to clip them out and then stick the next resistor in right next to the original contacts. Oh well, more sacrifices to the gods atone. Now just to confirm something, a sanity check, I'm going to quickly hook up my meter in milliamp mode. Let's go grab some voltage off the socket here. I got the Jet City I'm tapping voltage off of. Let's check the current draw, because this is supposed to be 600 milliamps, right? That's why I'm using it to do this test. It's gonna simulate two 12AX7s. All right, 4. Yeah, see? This tube's pulling 630 milliamps. So the simulation of 2 tubes. She's glowing. Theoretically, I tried it with this. I got massive voltage drop. How much current does this pull? Because I thought a mild-mannered 6L6 would also pull about 600 milliamps. Okay, this pulls considerably more. Probably settles into about 600 milliamps. Or no, it's 900 milliamps for a 6L6. All right, back to the drawing board then, bud. Well, if we clip here. Where's the next one? Right here. I'm often known to prototype certain things before I officiate them, but I think we can clip here. Clip here. It's funny, I bought these 2.2 specifically for this project and to make DC boards. Ugh. Burn! Okay, yeah, those resistors will still be useful in something else. We got plenty of lead on them. Now, this is one of the reasons why I'm not doing the elevated heater mod, because I've never done an elevated heater mod before, so I can't validate it. Until I've done it for myself, I'm not going to do it for someone else. This one I had validated with different value resistors, but nonetheless. Hote! We've taken a step backwards here. We can recover. Let's get our 1 ohmies. Ohmies. All right, I got those 1 ohmers lightly tacked on there. Let's test on this now and see what happens. Here, my wires are getting messy. So we're gonna connect to the diode bridge that's on here. We can't exceed 1.5 amps on this guy. All right, take this out of milliamp mode. And test 8.5 after rectification. Now let us hook up our double test tube here. You're not gonna be able to see the light glowing with the studio lights, but now let's check our output voltage. 5.57, 5.58. How's our diode bridge feel? Little warm, tube's definitely lit. Now let's test voltage drop across one of the resistors. 0.6 volts. Hote. Jeez, I should look at the Jet City. It only has like 1 amp diodes in there with the 1.2 resistors. Hasn't given me any grief yet. Let us do a current reading. Oh, according to this, we're only pulling 600 milliamps. So we're within spec now. That diode bridge is still getting warm. I don't like that. I guess that was a crappy part. I shouldn't have bought them. Maybe they aren't what they say they are. Or maybe they can run continuously with a little bit of heat. I suppose I should torture test this for a little while. Rob Robinette is recommending a 512 GBU4 Abridged rectifier. 1000 volt 4 amp. I have a GBU1006 here, which I believe is a 6 amp version. Yeah, I do not like how hot that guy's getting. Why does a 1.5 amp bridge get so hot? Oh boy. Okay, well, either way, 2 ohms is too much. 1 ohms is more on par. And even if I was gonna fine tune this, I maybe would want a little bit less. Like the 1 ohm, they're definitely generating a heat, so make sure you can space them out. Not a lot of heat. They're gonna drop as many millivolts as they're dropping milliamps, which is an interesting quick math you can do with a 1 ohm resistor. So I would drop a whole 900 milliamps if I hook up 3 tubes, 600 milliamps if I hook up 2. Now I feel like some of this voltage drop we're seeing is going to be fault of that diode bridge. 5.86. Realistically, I bet we could bypass one of those droppers and hit target 6.3. The other one starts to get much hotter though. It's still dropping 600 milliamps, so yeah, we're engineering a DC board based on an online schematic. Doesn't seem to apply correctly. In retrospect, yes, 2.2 ohms, 2 of them makes no sense. Unless he wants to run at a really low voltage. Maybe I should read all of this. Maybe as an explanation for this. I think I did at some point, but it's been a while. All right, so I figure I'm gonna keep those two 1 ohm resistors, let this guy run at 5.8, whatever. According to Rob Robinette here, we use 2 resistors to maintain voltage balance, so that we don't have more voltage on one side than we do the other. I guess that makes sense. Probably be quieter, whatever. However, that dinky voltage bridge has to go. I've pulled it out. I gotta drill holes bigger for the bigger bridge. It was just getting too hot, and it was like starting to heat up the capacitor next to it. Surely it's not hitting anywhere near 105C. I bought high quality capacitors, but still, bud, still. It's gonna sit a little wonky. We got her in there. We'll use a bit of artism, probably like flip it out. Now these big guys, I noticed they're on heat sinks when you pull them out of computer power supply, so I guess diode bridges are supposed to run hot. Now we gotta put this arsehole back together. Unfortunately, this particular DC board is getting a little half-arsed, isn't it? Not as clean, but you're learning. I'm learning anyway. I'm learning that we have to double check our math. He straight up explains that you have to do your math in there. So, my bad. Oh, look. It fits nice. It fits nice. Crisis averted, sir. Problem is, we gotta get this positive here, all the way over to here, without it coming too close to a screw. And we need room to connect the AC in there. I think this calls for a jumper. Now, when I was putting together the boards earlier, I kept the little pieces of metal I clipped off those components, so. All right, I think we're all back together now. I've left the jumper hovering a bit because I know I still have to get some wires into this diode bridge for the AC input, so it's fine. It's not getting in anyone's way. The lighting circuit still has room to go here. All right, let's test on it. 5.9. So, it just means our voltage is going to change based on what tubes we put up front, eh? Yes. Now, they're all rated for about 300 milliamps. So unless they pull just a little bit more, we should be okay. Either way, minimum voltage spec for tubes tends to be about 5.7 volts. And again, I'm using this in the Jet City, and it works great. I've had no problems with those tubes. If I look in it now, I have identical tubes in V2 and V3. And V3, the heaters look a little bit more brighter than V2. So again, we're using 1.2 ohm resistors in there. So yeah, I think we're good. So if you're gonna build a DC power supply for your heaters, for this amp, go with 1 ohm resistors, max, maybe something a little less. Maybe something like 470 ohms. Yeah, 470, or even a 560 ohm. Maybe even an 820, because I would like to see that just over 6 volts. Oh, well, okay. You know what though? I'm gonna leave it right here, just like this, at 6 volts, diminishing gains. I think you know it. And these 3-watt metal oxides are better suited. I think in one of my next parts orders, I am going to get some lower value resistors, 820s, 470s, in 3-watt metal oxides for this purpose, so that I can better this design and get a real nice DC going. In the meantime, 1 ohm's gonna do. So, I think I'm babbling here. I hope you've enjoyed this. Stay tuned for more Soldano, because next up, we actually have to wire this thing. We have to actually start installing this in there. Oh, yeah. Can't believe how much of a fail it seems that I'm doing on this DC power supply. Wow.